Hello everyone, I'm Jérémie, and I'm very happy to present the work done with my colleague Anke on making drone piloting accessible for pilots with disabilities. So flying drone is a fun activity. Pilots frequently enjoy using their drone for free fly, creating nice motions in the air, or to race with others. However, this can be complex. Pilots need to control and monitor the drone and to avoid obstacles. And we see many examples of situations in which somebody crashed the drone and possibly caused damage. So flying drones require perceptive, motor and cognitive skills. That makes the activity fun, but possibly too challenging for people with motor and cognitive impairments. Our project started with a collaboration with an association for children and adults with various disabilities and a Fablab, and both were already conducting an accessible drone piloting workshops named Dronons, tous ensemble, which means flying drone together. We observed that they created several material and contextual adaptations to support motricity and cognition of the pilots. For instance, they were using big 3D printed sticks on top of the remote controllers, forearm supports, or even adding colors, evoking the direction on the remote controller and on the drone. However, despite all these adaptations, the participants were struggling to pilot and stabilize the drone in the air, so the time actually spent flying was very short. As you can see on the picture, most of the drone are on the floor. So based on interviews and discussion with the organizer, we identified 8 requirements to guide our design activities. So our goal was to support fun, concentration, safety, perception, motor skills, stabilization, causality, and to limit complexity for the participants. Prior work investigating interaction for drone piloting for entertainment, but did not cover disabilities. There are existing devices that have been designing for being adaptable to various capabilities, such as the Xbox controller, that are very relevant to our work. And regarding the methodology, we based our work on ability-based design principles that suggest to focus on abilities, existing devices, and adaptability, for instance. We followed a research to design process, which aims not only to produce usable artifacts, but also to generate knowledge through an active process of ideation, iteration, and critique of potential solutions. We did 4 iterations of the CandyFly software over 3 years, conducted 8 workshops, and documented results for 11 participants, 7 male and 4 female, from 5 to more than 65. So let me present you CandyFly, the software application we built to adapt the degree of control to the user abilities by taking advantages of the drone autopilots and different input devices. So CandyFly can accept many input devices, from game controllers to classical remote controller for drone piloting, or custom-made one using Arduinos or Makis. And for instance, you can see on the picture a table with pressure-sensitive arrows we built with the workshop organizers. And this allows also to pilot many kind of drones, commercial drones or tinier one like CrazyFly or Parrot or Bebop drones. So this is the CandyFly graphical user interface that meant to be used by the workshop organizer, the pilot themselves, or their caregivers. The graphical user interface allows to calibrate the input device sensitivity and range to accommodate various resting positions and match force amplitude or movements via the range sliders. Thanks to the arrows, we can also select the degrees of freedom for the altitude, the rotation, front-back motions, or right or left. We can also adjust the speeds of the drone, the vertical one, horizontal, or rotation one. And there are also interactions for storing and recalling presets and take textual notes to accelerate workshops and store effective results that can be reused over time or served as a basis for new participants. So now I will present you the result from the flying workshop, in which we use CandyFly in various situations. In the first one, we fly gimbal, and participants were able to fly way more longer than they used before. We had them perform specific tasks such as landing on boxes using various input devices or tactile buttons or regular remote controllers. We also were able to conduct workshop outdoor, and here you can see the drone is moving much more faster to increase the pleasure for this participant, which has more skill and experience. For this participant, we used dot balls that were tactile using Maki to support takeoff. We also used the tactile table with the arrows that allows to trigger predefined motions in this case, but they were also be able to use in continuous mode, where, like in this example, where the pressure is mapped to the speed. And note that this user has severe vision impairments, but was still able to fly and enjoy using CandyFly. So the piloting workshops allowed us to evaluate and assess our interaction in various contexts. Among the main results, we found that pilots had fun flying drones, which was our main goal. We received many positive feedback from pilots, their family and therapists. For instance, as stated by the organizer too, P10 wouldn't stop. I had to change the battery 3 times in a row. We were also able to adapt to idiosyncratic abilities and preferences, covering various kinds of disabilities. And that was particularly appreciated by the workshop organizer to welcome new participants. An important aspect was the sense of control. We had to use speed control in the autopilot, fast as possible reaction times, and also multimodal feedbacks helped many pilots. For instance, in the last iteration of the table, we used blinking LEDs and sounds. And the organizer explained that the sound helped P8 to focus on piloting, but also had made it difficult for P7 to concentrate, who has to turn off the sounds. So again, adapting to idiosyncratic abilities and preferences proved to be very important, and CandyFly actively supported that. On a side note, I would like to stress that we had to discard many non-explicit interactions, such as shaking an object to make the drone go higher, or turning boxes, or various ones we explored. But we had to discard them because the causal link between action and reaction was not strong enough, according to the therapist and the organizer. While designing CandyFly and using it in the workshop, we identified and refined design principles spanning 3 areas of adaptation: hardware, software, and automation. And these 3 axes constitute a framework that helped us meet the need of the user and guided us to create the interactions. This framework provides guidelines for implementing the adaptation principle of ability-based design for leisure activities involving control of drones or robots. Since I won't have time to present everything from the framework, I will focus on one axis, the software one, and I will link it to the CandyFly requirements we formulated at the beginning of the project. So to support motor skills, we found that adjusting interaction to force and precision of pilot, set the 0 position, or filter for reducing tremor proved very useful. We also focused on the perception, complexity, and concentration aspects, mostly by limiting degrees of freedom and reducing speeds. And interestingly, this is clearly related to the fun principle. Being able to augment progressively the speed and the degrees of freedom was received very positively by organizers and participants. So to conclude, we used a research through design approach to create CandyFly, an application allowing pilots with disabilities to enjoy flying drones. CandyFly is still used during workshops by the association and will continue being. Among the perspectives of the work, we are focusing on including more types of users, such as visually impaired pilots, but also young children or elderly people. We're also considering releasing a complete do-it-yourself kit for anyone to fly using CandyFly. For now, only the source code is available on GitHub, but the plans for the table and the pressure-sensitive controller will be also made available soon. So thank you very much for listening, and I would like to thank all the pilots, organizers, and people involved in this project and our research. Feel free to reach us for using CandyFly for any question.